This is alpha carbon and this is alpha amino acid. Alpha amino acids. Proteins are the natural polymer of amino acid. Proteins are the natural polymer of alpha amino acids. That is so all the form actually for that is protein. This is one of the amino acid. Similarly, it is vary because of this R part. In glycine it is H, in alanine it is CH3. Like that, another amino acid, suppose if they combine C H, suppose this is R1, this is R2, COOH. Again NH2, CH, RCOOH. This is R3. Addition elimination. It attack, it pick up the electron, return किया यहाँ से H2 बार, यानी कि amide bond formation होगा. This is amide bond. एंड इस बॉन्ड को बोलते हैं, दो एमिनो एसिड के बीच जो बॉन्ड होता है उसको बोलते हैं पेप्टाइड बॉन्ड और पेप्टाइड लिंकेज. दैट इज पेप्टाइड बॉन्ड. पेप्टाइड बॉन्ड. अगेन सिमिलरली इट इज H2O removed and this is peptide bond. So it is three amino acids are used, two peptide bond it is there. So it is called tripeptide. And primary structure of protein is nothing but is polypeptide chain. जितने amino acid हैं उसी के बेस पर this is tripeptide structure. It is tripeptide. If it is three, not because of it is two peptide bond, but not dipeptide. It is tripeptide. Number of amino acid there are three. So it is tripeptide chain. Tripeptide chain. Classification of amino acid. Actually this amino acid it exists in deuterium. Amino acid exists in deuterium. Here it is CHCOO negative. This is deuterium. It is the proton of acid. It is basic part, it is acidic. This is called as deuterium. There are certain amino acids which can be synthesized inside the body cells. On the basis of synthesis, we have classified the amino acid into three categories actually. On the basis of synthesis of amino acid, that is classification of amino acid. Three part essential amino acid, one it is non-essential amino acid, another one it is semi-essential amino acid. Essential amino acid, the amino acid which can be which cannot be synthesized inside the body cells, and the amino acids which are required to take in our diet, that is essential. Essentially we have to take these amino acids from external source. प्रोटीन बनाने के लिए 20 टाइप्स के अमीनो एसिड की जरूरत है. There are 20 types. Out of 20 types, 8 अमीनो एसिड्स ऐसे हैं जिनको बॉडी सेल्स नहीं बना पाती, तो हमको फूड में लेने की जरूरत है. ऐसे अमीनो एसिड को बोलते हैं एसेंशियल अमीनो एसिड्स, रिक्वायर्ड टू टेक इन फूड. डाइट में प्रेजेंट होने चाहिए, मस्ट बी प्रेजेंट इन डाइट. बॉडी सेल कैन नॉट सिंथेसाइज दीज अमीनो एसिड्स. नॉन एसेंशियल, ऐसे अमीनो एसिड जिनको बॉडी सेल्स जितनी जरूरत है, बॉडी सेल्स कार्बन, नाइट्रोजन, ऑक्सीजन, हाइड्रोजन इनसे सिंथेसाइज करके बायोकेमिकल रिएक्शन से उनको सिंथेसाइज कर दे सेल के अंदर, तो उनको डाइट में लेने की जरूरत नहीं है. दे नीड नॉट टू टेक इन अवर डाइट. सो दीज अमीनो एसिड्स आर नोन एज नॉन एसेंशियल अमीनो एसिड्स. It is essentially must be present in diet because body cells are unable to synthesize. Essentially present. Essentially must be present in diet. Must be present in diet. In diet. That is essential. Because body cells cannot synthesize. But body cells can synthesize these amino acids. So need not to take in our diet. No need to take in diet because no need to be present in diet. No need to be present in diet. In diet because body cell can synthesize these amino acids. Because body cells can synthesize these amino acids. Semi-essential, there are, that is arginine and histidine. Example, arginine and histidine. ये जो पार्ट है सेमी एसेंशियल वाला, जितनी जरूरत है आर्जिनिन और हिस्टिडीन की, उसका कुछ पार्ट बॉडी सेल्स बना लेती है, कुछ पार्ट डाइट में लेना जरूरी है. दैट इज व्हाई इट इज कॉल्ड सेमी एसेंशियल. इफ द सेमी एसेंशियल कैटेगरी इज नॉट गिवन, इन दैट केस इट इज क्लासिफाइड इनटू एसेंशियल. बिकॉज जितनी जरूरत है पूरा बॉडी सेल्स नहीं बना पाती. Though it is 3 category, if we divide it into 2 categories, that is essential and non-essential, then this part goes to essential. फिर तो ये आर्जिनिन हिस्टिडीन भी किसमें आ जाएंगे? एसेंशियल में. एसेंशियल कौन कौन से हैं? वैलिन, ल्यूसीन, लाइसिन, आइसोल्यूसिन, फिनाइलएलेनिन, ट्रिप्टोफैन, थ्रियोनिन एंड मैथ्योनिन. These are essential. This is semi-essential and other 10 are non-essential. One more classification it is there on the basis of their nature: acidic, basic and on the basis of nature and neutral amino acids. Chemical nature, that is on the basis of chemical nature. Neutral amino acid, acidic amino acids, the basic amino acid. C. First, neutral amino acids. Glycine. This is the symbol. Here it is amino acid, it is in place of R, here it is H. This is glycine. Second it is alanine. ALA. Here it is again side chain. It is CH3. Valine. Side chain it is leucine. Isoleucine. This is side chain. Isoleucine and side chain is we can write its condensed form so that we can write all these 20 amino acids here. CH2 CH3 CH3. Fifth, isoleucine. C H NH2 COOH C this is isoleucine. If you see that Gavli, Gavli, G H CH3, 3 carbon containing isopropyl, then 4 carbon containing, 4 carbon containing. This is the side chain. C678. Next, methionine. The sulfur containing side chain is CHCOOH NH2 CH2 CH2 SCH3, or we can write these only side chain itself. Proline, it is sulfur containing actually. Where it is sulfur, it is present in this one. Methionine, MET. Number 7, proline, PRO. This is side chain, it is cyclic amino acids. Number 8, phenylalanine. Alanine, this is alanine. If it is attached with pH, that it converted to phenylalanine. Phenylalanine. CHCOOH NH2. Side chain it is CH2PH. Phenylalanine. After phenylalanine, tryptophan. This is the side chain. Here it is NH2, NH2, COOH. This is tryptophan, TRP. After tryptophan it is asparagine, number 10, side chain it is asparagine, ASP. This is the side chain. C double bond O, CH2, NH2, after that it is glutamine. One more carbon it is there. GLN, glutamine. Side chain it is CHCOOH NH2. Serine, side chain it is CH2OH. Side chain it is CH2OH. Serine. SER. Here it is CH2OH, CH. Number 13. Threonine. This is a side chain. CH3, CH2, CH3, CHOH, CHNH2, COOH. Threonine. THR. 14. Tyrosine. TYR. That is side chain is CHCOOH NH2. Cysteine. CYS. CS2SH. CH. These are the amino acids which are neutral amino acid, and we see their dielectric constant, that is isoelectric point. Isoelectric point of these, it is approximate near to 7, in between 6 to 7. It is 6, 6, 6. First 5 isoelectric point, it is 6. Here it is 5.4 asparagine, 5.4, and it is close to our neutral side. But if we see that acidic amino acids, acidic amino acid and basic amino acid, now see the acidic amino acid. There are two aspartic and glutamic acid. There are two acidic amino acid. Acidic amino acid. Take aspartic acid, that is 16, aspartic acid, ASP. It is ASN, it is ASP, aspartic acid, ASP. Side chain it is CS2, COOH, CH, COOH, NH2. Glutamic acid, one more carbonate is also added, that is GLU. CS2, CS2, CO, OH, CH, NH2, COOH, GLU. Next, basic amino acids. Here is the isoelectric point, it is very less. they are towards acidic side. There is 2.8 and 3.2. 2.8 it is isoelectric point, 3.2 towards acidic side, because side chain it is acidic. If you see that basic amino acids, there are 3 basic amino acids. One it is lysine, arginine and histidine. Lysine it is lysine, CH2, 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 NH2. Next it is CHNH2, COH. It is towards basic side. Isoelectric point it is 9.7. Isoelectric point it is 9.7. Number 19. Arginine. The semi-essential. Arginine. CH2. CH2, NH, C double bond, NH, NH2. Another it is CH. Its isoelectric point is 10.8. Number last, histidine. These two are semi-essential, or if it is semi-essential category is not given, then it is an essential. This is side chain. CH2, CH, NH2, COH. It is also basic side. Means side chain it is basic. Its isoelectric point it is 7.8. So these are total 20 amino acids, out of which 8 are essential, 10 are non-essential, and 2 are semi-essential. Semi-essential also they are counted as essential. These are 3 basic: lysine, arginine, histidine. 2 amino, that is acidic, aspartic and glutamic, and others are, that is butyl amino acids. Come to the next, isoelectric point. The pH at which, this is nothing, it is the pH at which amino acid do not migrate towards any electrode. Actually this NH2, it exists in deuterion. This amino acid it exists in deuterion. This is amino acid. If acidic medium it is there, in acidic medium it converts into, in acidic medium it converts into NH3, CHCOOH. In basic medium it converts into NH2 CH RCO O negative. This is anion. This is cation. This, and it exists in deuterion at neutral medium, means this at pH, isoelectric point it is nothing, pH at which net charge on an amino acid is 0. Net charge on an amino acid is 0 and does not migrate towards any electron, does not migrate towards any electrode, is known as isoelectric point. So the primary structure of protein, primary polypeptide chain of amino acid, it is nothing, it is linear polypeptide chain of amino acid is primary structure of protein. Linear polypeptide chain of amino acid is known as primary structure of protein. Structure of protein. In secondary structure, folding takes place, that is by hydrogen bonds. There are secondary structure, it is alpha helix and beta pleated sheet. So this is our amino acid. Okay, thank you students. Form the many monomers, they form polymer like ethene. This is the monomer. When ethene they combine and they gives the linear polymer. This is the polymer of ethene, and this process it is known as polymerization. Formation of polymer, it is known as polymerization. See the classification of polymer. There are different bases of classification of polymers. One of them is on the basis of on the basis of units. If same type of, that is, it is two type, homopolymer and copolymer. Homopolymer and copolymer. If the same type of unit, if they combine in a polymer, if same type units are repeated, that is, if same type of units are repeated, if, or we can say only one type of monomer are used in to form the polymer, then it is called as homopolymer. If only one type of units of monomer are used to form the polymer, one type of units of monomers are used, then it is called as homopolymer. Example, glucose, that is, they form starch. They have alpha D glucose, monomer is alpha D glucose, In copolymer, if more than one types of units are present, if more than one type of units are present, more than one types of units are present, that is nylon 66. Example, nylon 66. Here it is adipic acid and hexamethylene diamine, plus adipic acid. Hexamethylene diamine, it is NH2, CH2, CH2, CH2. This is hexamethylene diamine, and adipic acid is COOH, CH2 whole 4 COH, and it removes the water molecule, and again same repeated unit it is, it forms the nylon 66. So two types of units are used when it is hexamethylene diamine and adipic acid, so it is copolymer. Again, copolymer, it is further divided into four categories. Copolymers, again it is divided as alternate copolymer, random copolymer, next it is block copolymer, and graft copolymer. Alternate copolymer, suppose A, B, they are two different, A and B, then A, then B, then A, then B, and so on. Random copolymer, A, Now B, B, A, B, 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 A, B, B, A. Means randomly they are just A, B, B. Block copolymer. There are the block of A. Then B. Then A. Blocks. Then B. In case of graft copolymer, suppose one of the polymer, they form the linear form. Suppose A, and it is under branch now, branching by B, like that. Classification on the basis of source. Natural polymer and that is synthetic polymer. Natural polymer, synthetic polymer. Another it is semi-synthetic polymer. Semi-synthetic polymer. See the natural polymer. Example. First, the polymer which is synthesized by nature. जो पॉलीमर नेचर ने बनाया नेचुरल पॉलीमर, लाइक स्टार्च, ग्लाइकोजन, सेलुलोज, डीएनए, आरएनए, etc. They are made up by nature. So natural polymer. Synthetic, PVC, polyvinyl chloride, polythene, polyethylene. That is made by man-made polymer. Synthetic polymer means man-made polymer. Again, semi-synthetic polymer. The polymer in which nature synthesized the polymer and modified by human beings. Means some part of the polymer it is synthesized by nature and it is modified by man-made. दोनों का ही वर्क है. ऐसे पॉलीमर को बोलते हैं दैट इज सेमी सिंथेटिक. एग्जांपल सेलुलोज नाइट्रेट, सेलुलोज जेंट्रेट, etc. Classification on the basis of shape. Are there three types? One When it is linear polymer, branch polymer, and cross-linked polymer. Linear, branched, linear के साथ साथ ये branching हो जैसे polymer में. Cross-linked, suppose linear it is there, linear form they are cross-linked by the branching, branched copolymer. Classification on the basis of synthesis. When it is addition polymer and condensation polymer. In addition, ऐसा पॉलीमर जैसे सिंपल एडिशन होता है जैसे स्टाइरीन, एग्जांपल स्टाइरीन. कंडेंसेशन, एडिशन के साथ साथ स्मॉल मॉलिक्यूल रिमूव हो जैसे नाइलॉन 66. एडिशन along with addition H2 molecule it remove, that is example nylon 66. Again addition it is radical addition, cationic addition, anionic addition. See, in condensation polymerization it is hexamethylene and adipic acid CH2 COOH COOH. It is 6 carbon containing, that is why it is formation, it attack, it pick up the electron, it return, it remove the H2. When H2 is removed, so it form the amide bond minus H2. Similarly again COOH, CH2 whole 4, COOH, it remove the H2 molecule, so it form NH. So H2 molecule it is removed and dot dot dot. Again here it is NH, CH2 whole 6, NH dot dot dot. So it removes the small molecule, that is condensation. This is nylon 66. It is only simple addition takes place. See, again addition it is 3 type. Radical addition, polymerization. Radical addition, A. Radical addition, polymerization. Here the radical, suppose styrene, polystyrene, that is CH double bond CH2 and molecule of this in presence of radical like R, O, OR, H neutral homolytically, it form the radical and it gives the polymer. How it gives the polymer? CH, CH2R, CH, 2CH, PH, CH2, CH, PH, and so on. So you see the mechanism. ROOR, it cleaves homolytically. H nu in presence of H nu, OR radical plus OR radical. With OR radical it affect CH double bond CH2. It cleaves homolytically and form the radical. CH2 OR radical again, it cleaves homolytically. Next it react with this and so on. Again this radical it add and simple addition takes place. That is addition polymerization by radical mechanism, and so on. It gives the polymer, polystyrene. This is styrene converted into polystyrene. Polystyrene. It gives, that is n repeated molecule of n of this structure CH2CH. This is polystyrene. Styrene converted into, this is styrene. Styrene is monomer. Polystyrene is, it converted into polystyrene. This is as a polymer. Mass radical mechanism. This is addition, nothing, no small molecule removed. Another one it is cationic. B. Cationic polymerization. In case of radical, finally we add some small amount of radical to stop the reaction. In case of cationic, again styrene converted into, same cases, 10 molecule of styrene gives the polystyrene. Presence of cation. What happened is, if you see that mechanism, this is again styrene, CH, CH2, when H plus it is added, either H2SO4 or acid it is added, what happened, it gives the cation, that is CH3, CH positive, it is वहाँ cation as intermediate. Cation intermediate के थ्रू रिएक्शन चलेगी, क्या होगा, फर्दर अगेन एडिशन होता जाएगा, and so on. So we obtain the polystyrene, that is CH2 finally this reaction it stops when anion is added. On addition of anion, reaction, on addition of anion, reaction gets stopped. Reaction reaction stop on adding of anion. What actually happened when anion is added? It reacts with cation and reaction gets stopped. Third, it is anionic polymerization. Anionic polymerization. Similarly, it is reaction like again styrene. And mole of styrene, it gives the polystyrene. On adding the anion, like NaNH2 is there. See the next one is when anion it is added, it is via intermediate anion. CH negative, it is resonance stabilized. Further reaction, and so on. It gives again polystyrene, CH, CH2, N molecules, that is polystyrene. On adding the H plus, reaction can get stopped, means to stop the reaction, you have to add it H plus or acid. Thermoplastic and thermosetting polymers. Thermoplastic and thermosetting polymer. Thermoplastic polymer and thermosetting polymer. This polymer, if they melt, they can again convert it to another shape. They will not disturb by giving the temperature on heating. These polymer can be changed in another shape. A polymer which can be melt and can be converted into another structure or shape. ऐसे को बोलते हैं थर्मोप्लास्टिक. एग्जाम्पल PVC. The polymer which cannot melt again or which cannot convert into another shape. एक बार अगर सेट कर दिया, एक बार अगर शेप दे दिया तो उसे फिर से मेल्ट करके दूसरी शेप में कन्वर्ट नहीं किया जा सकता. जैसे रेजिन्स, बेकेलाइट, फॉर्मल्डिहाइड रेजिन, बेकेलाइट, मेलामाइन फॉर्मल्डिहाइड रेजिन, फिर phenol formaldehyde resin, that is bakelite. Phenol formaldehyde resin, that is bakelite. So they cannot convert into another shape. They can be converted into another shape. Then it is there Ziegler-Natta catalyst. Trialkyl aluminium and titanium tetrachloride. This catalyst is used for high density polymer. Used for high density polymer. This catalyst this is a catalyst, high density polymer. Next, examples. In our booklet there are 25 examples. It is given monomer, polymer. You can see that one. Okay, thank you students.